everyone, I'm Brinleigh Murphy-Reuter, CEO and founder of Science to People. Thank you so much for having me as a part of the Pacific AI event today. So over the next 10 minutes, I want to walk you through a few things: the problem we set out to solve, the technology we built to solve it, and why responsible deployment, not just building a good model, is the hardest and most important part of all of what we're doing. So at the end of my segment, I'll hand it over to Anju from Pacific AI, who will walk you through the governance framework that we built together to make sure that this technology can actually be trusted in the field. So let's start with the problem. Here's the reality where we're working inside. More than 50% of adults in the United States are getting their health information from social media. That is the primary information ecosystem for most people. It's probably the same for you. And on the content creator or influencer side, the communicators who are doing this work, the ones that the public actually trust and follow, now they're spending an average of 6 to 8 hours of research to produce content on a single topic. That's a full work week in a lot of cases over the month just to get one piece right. So the institutions that are supposed to be the source of truth that were built for all of this type of information were really built for press releases and policy briefs. They were not built for the creator-led media ecosystem. So ultimately, the people that the public trusts online often have no reliable way to access clear, vetted scientific guidance. And the general purpose AI tools that exist right now, they hallucinate facts, they lack science communication nuance, and they miss the needs of diverse audiences entirely. So what's needed is an AI that is communicative, contextual, and grounded in real science. And that's what we're building. So Science to People exists to close the gap at scale. Our theory of change is simple. If creators, communicators, and institutions are given evidence-based accessible tools to translate science accurately, and if those tools are culturally attuned, simple, and engaging, then they will create content that builds public trust and understanding. So over time, that leads to a healthier, better informed public that is empowered to make science-based decisions. So at Science to People, we build AI-powered tools that do exactly that nuanced translation work. We're here to serve the creators and institutional communicators who are already trusted voices in their community. And our approach is grounded in serious research, including Harvard's Influencing the Influencer study. And we're developing this work with partnerships at the National Academy of Medicine, the de Beaumont Foundation, NORC at the University of Chicago, and Yale's PopHive Initiative. So I'm going to show you what we are actually building. So the core of what we're building is the VeriSci language model. This is a fine-tuned language model, purpose-built for expert science communication, but at the scale of digital media. And I want to be really clear about what that means because it matters for the governance conversation that Anju is going to have with you. This is not a generic AI model with a science communication prompt plopped on top. This is a model that has been fine-tuned specifically on science communication best practices. It's been validated by experts and specifically structured to reduce the specific failure modes that make general AI really dangerous in health contexts. So here's how the backend works. It all starts with evidence, right? So we have the fine-tuned language model, but then we pull from a RAG of over 10 million peer-reviewed full-text academic articles. We have retraction tracking and quality ranked journals kind of reweighted in the system. And then we have another layer of science communication. So this is the fine tuning across the 6 core dimensions, including understandability, actionability, framing, health equity, numeracy, and metaphor. Then layer 3 is issue specific. So topic scoped retrieval with partner framing guardrails to reduce hallucinations. And layer 4 is style and tone. So this is audience contact, the voice of the communicator themselves, and format adaptation. So oftentimes the way you show up on TikTok might be different than your LinkedIn. We take all of that into consideration. So then obviously the final layer is the publish ready output. So this is accurate, engaging scripts, caption, press releases, posts. And that whole pipeline powers 2 platforms that you see at the bottom there. Akari is our creator platform for digital science communicators, and Comms Companion, or VeriSci Content Studio, is our enterprise tool for public health institutions. So the fact that this model is specialized is exactly what we think makes it governable, which is exactly where Anju and Pacific AI come in. And this is where we are right now. I want to be completely transparent about this because I think that honesty is a part of what makes the governance story credible. We're in pilot right now with about 100 users. Public health communicators and creators are using this tool today, but those pilots are currently running on prompt engineering, not yet the fine-tuned VeriSci language model. That was because we developed where we saw a number of inconsistencies in output, and we wanted to make sure we got it right before we ever launched it to the broader public. So we're actively working on getting that ready for an upcoming sprint with Pacific AI. And that sprint is going to back our responsible deployment. So we can't just flip a switch, right? We need real certification framework, not just a safety checklist. So the framework that we're going to be running with Pacific AI in the next couple of months has 4 key pillars: regulatory alignment, expert benchmarking, automated guardrails, and standardized transparency for this kind of burgeoning health and health communications AI industry that requires healthcare specific benchmarks. So that's exactly what we're building with Pacific AI, and that we're so excited to be able to get that kind of external validation on the quality of the language model that ends up powering all of our suite of products at Science to People. So grateful to Pacific AI, and now I'm going to hand it over to Anju, who will walk you through how all of this works in practice.
Thanks, Brinleigh. That was a great overview and a strong case for why we need a structured certification framework for responsible AI deployment. Building on those 4 pillars, I'll focus on 2 today: expert benchmarking and standardized transparency, and how we operationalize them in practice. So the key question becomes, how do we actually evaluate these LLM systems in a way that builds trust? In high-stake domains like public health, evaluation can't be an internal-only exercise. It needs to be independent and objective. That's where third-party evaluation becomes critical. At Pacific AI, we are building evaluation platforms specifically for public health communication. In these use cases, it's not just about correctness, it's about clarity, safety, and real world impact. To support this, we have developed Guardian by Pacific AI, a structured end-to-end evaluation framework for LLMs. It enables expert benchmarking through comprehensive testing across safety, bias, hallucination, and robustness, using both standard benchmarks and custom use case specific datasets. And it drives standardized transparency by generating structured outputs like model cards, evaluation metrics, comparative leaderboards that clearly identify top performing systems. All of this is done through independent evaluation, helping remove bias, strengthen trust, and identify risks before they reach users. Before I go deeper into the details, let me quickly walk you through how we approach testing using Guardian. First, we start with what we test, combining industry standard benchmarks with custom datasets tailored to the specific use case. Then we move on to how we test, where Guardian helps us detect issues, debug the root causes, and compare how models perform against each other through benchmarks and leaderboards. Once testing is complete, we focus on how results are captured by publishing them in model cards that clearly document performance, safety, and limitations. And finally, why all of this matters. This structured approach creates auditability, supports governance, and ultimately helps build more reliable and trustworthy AI systems. We combine standardized benchmarks with real-world use case specific testing to get a comprehensive view of model performance. We start with industry standard benchmarks to establish a baseline. For this use case, we selected 3 benchmarks relevant to public health communication. Medication QA is built from real consumer medication questions and helps evaluate how well the model handles consumer-facing education and safety scenarios. We also use targeted test suites like race bias, which focus on fairness and safeguard validation, ensuring that responses do not unintentionally introduce bias or harm. Similarly, MedHalu, it assesses reliability and helps detect potential misinformation, which is critical for safety validation before deployment. In addition to benchmarks, we use custom datasets tailored to the specific use case. In this case, a public health chatbot, including edge cases and high-risk scenarios. For example, the influencer public health dataset, it focuses on high-impact situations where miscommunication, oversimplification, or commercial influence could lead to population-level risks. And once we define what to test, we run these evaluations on the model to assess performance and identify potential risks. In the detect phase, we run curated test dataset on the model using Guardian to evaluate performance across key dimensions. Each dataset is designed to assess specific dimension of model behavior. For example, medication QA, it evaluates clarity, readability, appropriateness of explanations, and safety of advice. Race bias focuses on fairness and safety, ensuring that public health communication does not perpetuate harm. MedHelu assesses critical safety and reliability, particularly around misinformation and hallucinations. And the influencer public health dataset evaluates how effectively the model communicates in high impact scenarios, including clarity, active listening, evidence-based responses, avoiding assumptions, and preventing missteps. These datasets are typically run on the target LLM, and in this case, VeriSciLM, to generate performance scores across each dimensions. The scores shown here are based on the evaluation of a medical LLM developed by John Snow Labs, and these scores are automatically generated and visualized within Guardian. This step provides early detection of potential issues, as each datasets include targeted scenarios designed to uncover risks. At this stage, we are not fixing anything yet. We are making the risk visible. In the debug phase, we focus on identifying the root causes behind the issue detected, whether they stem from prompts, model behavior, or data gaps. Using Guardian, we generate detailed evaluation reports, particularly for custom datasets. These reports are powered by a LLM-based evaluation framework that acts as an automated judge for conversational responses. Each response is assessed against defined evaluation criteria, and the report highlights failed test cases along with the specific reason for failure. Importantly, the reports also provide actionable recommendations such as refining prompts, adjusting model parameters, or improving training data to address the identified issues at their root cause. For example, in one test case, the model was asked how the COVID-19 pandemic changed how people think about vaccines. The evaluation required clarity and specific guidance, but the response was found to be vague and lacking actionable detail. The recommendation in this case was to use structured prompts for actionable outputs. This allows teams to systematically refine prompts, improve data, and strengthen model reliability. In short, this is where detection turns into actionable improvements. Building on our evaluation framework, this also gives us a standardized way to compare VeriSciLM with other LLMs. Instead of evaluating models in isolation, we run side-by-side assessments across key dimensions like safety, bias, hallucination, and clarity. All models are tested using the same benchmarks, including both public datasets and the use case specific scenarios, ensuring a fair and consistent comparison. This allows us to generate transparent, decision-ready insights that help identify which models are best suited for real-world deployment, especially in high-stakes domain like public health. Once we complete the detect, debug, and comparative benchmarking phases, the next step is to make these insights structured, transparent, and usable. Guardians enable this by automatically generated CHAI-aligned model cards, a standardized framework developed by the Coalition for Health AI for Healthcare AI Systems. These model cards are generated from test results, evaluation reports, and system configurations, and can be refined as needed. As models are fine-tuned and re-evaluated, these model cards are continuously updated, ensuring results remain reproducible and consistently tracked. This means all insights from performance metrics to identified risks are captured in a clear, shareable format. And in public health, this level of transparency is critical, enabling validation, governance, and ultimately responsible AI deployment. What we have discussed is not just about testing a model. It's about building a structured and repeatable approach to evaluating AI systems, starting from benchmarks and custom datasets to detecting and debugging issues, and finally documenting everything through model cards. We create a complete evaluation lifecycle. At the end of this process, Science to People has a validated deployment-ready LLM along with an audit-ready model card. Together, these outputs demonstrate the system's safety, efficacy, and advantages over generic LLMs, enabling confident deployment, audit readiness, and scalable operations. This approach ensures traceability and helps teams identify risks early before they impact real users. And this brings us back to Brinleigh's point that this isn't just a safety checklist. It is a certification framework that enables trust, transparency, and responsible deployment at scale. So that's how we move from testing to trust through structured evaluation, risk visibility, and transparent documentation.